Hey guys, what's going on? We're going to be doing shear moment diagrams for now. We're going to get started with problem 7-7 from chapter 7 of Hibbeler. Okay, this is where it kind of starts getting into plotting the shear moment diagrams, not just finding the internal forces at a given point C or something like that. Okay, this is usually the part where most students get confused and get lost. So let's get started. All right, so you're going to be giving a beam, all right, and then they want you to plot the shear moment diagrams as a function of x. Okay, so what you're going to have to do is find the reactions in the reaction forces at a given point in this beam. Okay, and then find the equations for those reactions. For those internal forces. So the first thing we got to do is determine what kind of supports we have. So here we have a solid support. So we're just going to draw, we have a solid, like a wall, a fixed support to get more technical. So we have AY, AX, and then we're going to have, this moment wants to push it clockwise. And we're going to have a reaction moment here, MA, okay? And the first thing we want to do is just solve for these. So Fy equals 0, okay? And there's shortcuts to this as well, but we're just going to do it the old-fashioned way, okay? Just until you get, good hang of it. So find your supports or reaction forces. So Ay minus 6 equals 0. So Ay is 6 kilonewtons, okay? We know if we sum the forces in the x, Ax will equal 0, okay? So we have this and this, okay? And then we're going to have a moment equation. Let's sum moments about A. So we're going to have, I drew a moment at A in the counterclockwise direction. So I'm going to say MA. And then the 6 kilonewton force over here, right? That's going to cause a negative moment, 6 times 3, which means I have a reaction moment of 18. Okay, so now I've got my reaction forces. All right, good. Next thing is we're going to make the cuts, all right? And we're going to make the cuts along the beam before and after something happens. Okay, so by that I mean, so before A there's nothing, right? So I can't really cut it before A, obviously. So I have to cut it after A and before this 6 kilonewton force happens. Okay, so another example would be, let's say I had another force here, right? I would cut it after A but before this force, and then after this force but before this one. So I'd make 2 cuts, so before this force and after this force, and before this one. If that makes sense. Okay, so in this case I only have to make 1 cut. Okay, so let's cut 1 1. Okay, and then what you're gonna have is a little tiny beam portion like this big, okay, of size X. All right, and let's switch colors here. So here's point A, right? So we know at point A I have AY at 6, and I have AX is 0, so I'm not even going to draw it. And then I have a counterclockwise moment here of 18 kilonewton meter. Let's sneak it in there. Okay, and now let's draw the reaction moment at point 1. Okay, or sorry, the reaction forces. So I have a shear force V1. Okay, I have a reaction moment here, internal moment M1, and then a normal force N1. Okay, these represent my internal forces, internal moments. Okay, so when we make a cut and we look at the left hand side of the cut, like we're doing here, this is your standard format. The shear goes down, the the moment goes counterclockwise and the normal goes straight to the right. Okay, if you cut it, if you look at the right hand side, this is just a brief introduction. So if we cut it to the right hand side, we would draw everything opposite. So V1 this way, a clockwise moment, and then N1 going in this direction. Okay, let's erase that. Okay, and then the rest is simple here. So now we just have to sum forces in the Y. Okay, I have 6 kilonewtons going up minus V1. Okay, and this tells me that V1 is 6 kilonewtons. All right, and then take a moment about 0.1. Oh yeah, we know N1 is 0 because if you sum the forces in the X, N1 equals 0. Summing the moment about 1, well, I have M1 acting there, okay, going counterclockwise. And then I have plus 18 from here, okay. And then last but not least, I have a minus 6x, okay. So those are all the moments at point 1. And now let's just get our equation here. So M1 is 6x minus 18. So these are our two equations, okay? M1 and V1, okay? And this cut is from 0 to 3 pretty much, okay? And that's it. So now you've solved your internal force, your internal shear and moments, okay? So all you have left now is to plot this thing, okay? Here it's kind of simple because we only have one function for V and one function for M. But in the next few ones that we'll be doing, we're going to have like 2 or 3 different functions for each one, for V and for the moment. So let's plot this. So I have, I'm not going to make it pretty, but let's just, okay, this will be X, the length of the beam, and this is V, okay? So and this is 3 and 0, okay? So my function V doesn't vary with X. It's just a constant 6 kilonewtons, okay? So then I know that my shear force the shear force diagram is just going to be a constant 6 all the way across, and then it drops. So like this is all I have. Blah 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 blah. You know, make it pretty. There's the only art you're gonna have in engineering. Okay. And then the next one is the moment diagram. Okay. So again, here's 3. All right. And now let's look at this thing. This thing does vary linearly with X. So we plot the first point we're going to do is at 0, okay? So we put in 0 here, we're going to have a negative 18, right? So we're going to have, let's say, minus 18 down here, okay? Then at 3, okay, we're going to have 0 moment, okay? So at the ends of a beam, most of the time you're going to have 0 moment, okay? And in this case it's true. We plug in a 3, we're going to have 18 minus 18, which is 0, okay? And that's how our moment varies, okay, with the length of the beam. Now do a little cross hatching here, bada bing bada boom, okay? And this is the general format of doing these shear moment diagrams. Some professors might want you to like draw it right underneath the beam. You know, it just depends on your professor. Okay. So yeah, and then one more check you can do is to make sure your answers are, aligning with each other. Once you have your moment, take one derivative with respect to x. Okay, so we do dm dx, right? When we take the derivative of this, it's just 6, right? Which is equal to my shear force, okay? So the derivative of your moment with respect to x, okay, should equal what you have for your v, okay? So yeah, so the slope of the moment, that's what it's telling you, is equal to your v. All right, so here we have a positive moment, sorry, a positive slope, so we should have a positive v, okay? And then yeah, this pretty much a nice introduction. They're easing you into this, okay, into the shear and force diagrams, shear, force, and moment diagrams. All right, I hope this helped. I'm hoping to do a few more more complicated ones, so we start to get a hang of it. All right, I'll see you in the next video. Questions, comments, just drop me a comment down below and I'll be quickly and answer them. Alright guys, take it easy.